Okay, here we go into 5-3, which is interdependence, how living things depend upon each other to survive. And I address that as a vocab word, an important vocabulary word at the start of 5-1. So we're going to get into a lot of really interesting stuff here. So here we have our clownfish, which has an interdependency with the sea anemone, which I explained before. And then over here in these pictures, we got a few other scenarios. So I think they're referring to these two organisms have an interdependence with this zebra, and they actually can be good and bad. So there's some different terms I'll be getting into. When it's totally positive, like these two, it's called mutualism. And in the case of this flea is what we call a parasite. So that is not so good. So it's good for the flea, but it is bad for the zebra. And so that would be what we call parasitism. And there's these little birds that will actually go around on zebras and giraffes especially, and they go through their fur and they pick out bugs. And that helps the larger mammal and by getting rid of bugs and stuff, and then also helps the bird because it's getting food. So that would be another example of mutualism between this bird and the zebra and giraffes and stuff. All right, so we're going to start with chemical energy flow, which is chemical energy, which we usually refer to as food or nutrients, is exchanged between organisms at different levels within ecosystems. So let's take a look at this, and you guys did an online food sort of interactive food web activity by now, or you should have, or it's due tomorrow actually, but not tomorrow based on when I put this video out, but it's Saturday night right now, so it is due tomorrow, at least in the world I'm in. But when you guys watch this, it will already have been due. Anyways, so let's start here. So here's our energy source, the sun in this case, and down here we have phytoplankton or algae in the ocean that's going to use the energy to do photosynthesis and create chemical energy or food for the next level up the food chain, let's say. So here we see that we have these little animals, which they're calling zooplankton, and they are consuming the algae and getting nutrients. And then as we keep moving, we see the fish eat the zooplankton, and it's now flowing. Well, let's go back. And then the fish can be eaten by the seal, and then eventually maybe the seal can be eaten by the polar bear. And we notice there's no arrows pointing from the polar bear because polar bears are apex predators, which I addressed that term in 5-2. So now eventually they can be decomposed or something like that, or maybe they die and an animal eats them, but they do not have a predator within this food web. We also see the detritus, which was a term in 5-2, going to the bottom of the ocean, and we have like a lobster eating the detritus. So the lobster could be seen as a detritivore. And I think I've had students tell me who are Jewish that that is why some of these animals are seen as not kosher because they eat the detritus. All right. So this picture is a little crazy, definitely photoshopped. And I'm using it to represent trophic levels. So trophic levels are each step or point of transfer in an ecosystem's energy flow system. Oh, and let's go back here. So I was going to talk about the flow. So here we have the energy flowing. So just follow the arrow. It's flowing here to the algae, to the zooplankton, to the fish, to the seal, to the polar bear. So that's the flow part. All right, so trophic level, again, is each step or point of transfer in an ecosystem's energy flow system. In other words, it's every link in a food chain. So here's our producer, and then the dragonfly, there's actually a little insect on it because dragonflies are predators. So maybe there's a bee or something. It looks like a bee right there. And then the bee so we go from the producer to the herbivore. Here's our first carnivore, our next carnivore, and then here it's saying the snake would eat the frog as it moves through the food chain, or as we move through the trophic levels. All right, so a food chain is, here it comes, is the linear, meaning it's moving in a straight line, it's not branching, exchange of chemical energy or food between a group of organisms in a community. And so here are our producers on the bottom. So we have the phytoplankton or algae and the plant. And we move up, and we see we go through 1, 2, 3, 4 trophic levels. So it's like a trophic level is kind of more as it moves through the levels. So 1, 2, 3, 4 trophic levels. So here we have our producers moving up to the herbivores, our primary carnivores or secondary consumers. Don't really worry about these terms. Carnivore, now the next level, carnivore, so it's like a rattlesnake and then like a larger fish. And then we get up into our apex predators like this hawk or this killer whale. So when I was a kid, food chain, that term was used a lot, but eventually it's not really a very complete term, so that's why we need food webs. So here's a chain. So here's our source of energy. Let's move through the flow. Our producer, our herbivore, our carnivore, a higher level carnivore. And what it's saying here is that the hawk is going to eventually get decomposed by the fungus, which is why I like this picture because it includes the decomposer, and the nutrients can be reused to feed the grass. And actually all of these should point at the decomposer, which I'll show you with some of the other pictures I have. So here we have a food web. So this is called radial, as you'll see coming in here. Where's my arrow? Oh, it's not letting me use the arrow while my little animation happens. Okay, there it is. So it's a radial exchange. Radiate means to like go in different directions. So like heat radiates into a room, or smells are a little different, but energy can radiate and go in different directions. So so this is the radial exchange of chemical energy between all the organisms in a community, and these are made of many food chains. So here we have our producers, and we start working our way through our consumers until we get up to our apex consumers. And in this case, the most apex consumer does appear to be the fox because it has the most arrows pointing at it. Owls can definitely be up there too. The arrow, there should be an arrow. I didn't make this, but there should be an arrow from the mouse to the owl. So the owl may actually be more of the apex predator depending on how big it is. But I sometimes say that in the drawings that the main apex predator, one way to look at it, is the one with the most arrows. Plus no arrows leaving it. So there's no arrows leaving the owl or the fox, but since the fox has more arrows, we'd say, okay, maybe it's the most apex of the predators. And if I haven't explained apex already, I don't think I did in the other lecture. Apex is like the top of a mountain or like the peak. So it's saying it's like at the top. So we could break this down into multiple food chains. So what I want you to do right now is take a look and see if you can figure out the longest food chain within this food web, the one with the most trophic levels. And I'm not going to actually point it out. I'll point out a short one to make a point. So we have this leaf pointing, now the mouse is eating the leaf, and then the fox would eat the mouse. So that only went up a couple trophic levels. So I'm going to have a question at some point online. I'm working on this online sort of quiz type thing. And I'm going to ask you guys to identify the food chain that moves through the most trophic levels. So you need to definitely look at this picture and analyze it when you answer those questions later. All right, let's move on. All right, I really, really like this one because it's really thorough. It's got let me turn off this timer that's about to go off. It's got the decomposers down here, which I really like. And notice all the arrows are pointing at it. So this artist really knew what they were doing, and even went even further. These molecules represent the nutrients. So they're even showing molecules and stuff. So here it's saying this pine tree is going to absorb the nutrients from like the soil that the decomposers provided, and then it's going to flow into, let's say, this pine borer, and then this golden crowned kinglet can eat the pine borer, and then the golden crowned kinglet might be eaten by the red-tailed hawk. And that would be like a food chain. Or we could break it off, and the pine borer is going to the salamander, and we see it starting to web, or this bird can go to the snake and things like that. And then, but it shows with these red arrows that all the organisms go back to the decomposers, which I really like, and then we get the nutrients cycling and flowing back into the community and ecosystem, and that's why we need healthy ecosystems to keep this flow happening. Here's another one. This one includes something else that The other one didn't, which I like. It doesn't have the decomposers, but well, sort of, not as extreme though. But it does have the detritivores, which are misspelt by whoever made this. But it shows some worms and some insects and stuff, and those can help break down nasty stuff. And they're not really as functional as a true decomposer, but they do help get rid of some of that gross stuff. Obviously, our apex animal is the grizzly bear, and we can break down a bunch of different food chains from here. So I may again be asking some questions as I work on this new online sort of quiz. It's not a quiz, it would be like something you can fill in, and not fill in, what am I trying to say? It'll be like a multiple choice interactive thing on a program I'm trying to figure out. So I'm not going to really break this down because I want you guys to maybe identify the food chain within this image that has the most trophic levels or moves through the most. So let's find a really short one. This one is super short. It's saying, here's our producer going right to the decomposer and detritivore. So that just went up one trophic level. Let's find one that's a little longer. Okay, so we have the seeds going to the chipmunk to the hawk. So that's a pretty quick one. So at some point I'll try to have you guys figure out with this online question using this picture what food chain within this web would have the most trophic levels. And then I'm going to stop on this one. So this one's cool because it kind of puts them in chunks as it moves up. And it also has the detritus, which is stuff sinking to the bottom of the water. Also identifies the decomposers, which I like. But doesn't have arrows going down, which it should. But here we have our producers. This is like a marsh or like a wetland. And we have the producers creating the energy. We start moving up into lower level animals like this mussel and sandhopper, grasshopper. And then we start moving into the next level, sort of like these are like the herbivores into the carnivores. So, and this one's cool because it even identifies omnivores like the clapper rail and the harvest mouse. And the shrew is just a straight up carnivore. So it doesn't eat plants at all, I guess, according to this picture. And then we have some plankton eating fish, and the heron and the hawk would be like our apex consumers. And again, if I ever ask a question about what animal is the most apex, we're going to go with which one has the most arrows. Obviously that's the hawk, although the heron probably has a lot more arrows. Herons are big predator birds that walk around in the water, kind of like a stork or a crane and things like that. You may have seen herons flying around Southern California. So, all right, there's part one of our interdependence notes.